What is quantum computing? Who invented quantum computer? The concept of a quantum computer was first proposed by the physicist Richard Feynman in the early 1980s. However, it was the work of several researchers in the 1990s and 2000s that led to the development of the first functional quantum computers. One of the earliest pioneers in the field was the physicist David Deutsch, who proposed the first quantum algorithm in 1985. In 1994, Peter Shor developed a quantum algorithm for factoring large numbers, which is still considered one of the most significant achievements in the field. What is quantum computing? Quantum computing is a type of computing that uses the principles of quantum mechanics to process information. It differs from classical computing, which uses bits to represent information, in that it uses quantum bits, or qubits, to store and manipulate data. Qubits have the ability to exist in multiple states simultaneously, a property known as superposition, which enables quantum computers to perform multiple computations simultaneously, leading to much faster processing speeds. Another key feature of quantum computing is entanglement, a property that allows qubits to be connected in a way that their states are correlated, no matter how far apart they are. This allows quantum computers to perform complex calculations that are not feasible with classical computers. Quantum computing has the potential to revolutionize many fields, such as cryptography, drug discovery, and climate modeling, but it also presents unique challenges such as the need for stable qubits and scalability. The current state of quantum computing. There are still significant challenges that need to be addressed, such as error correction and scalability, before quantum computing can be fully realized. With continued investment in research and development, we can expect to see significant progress in the field of quantum computing in the coming years. Quantum computing in 2024. It is expected that the field of quantum computing will continue to advance in the coming years. By 2024, we can expect to see significant progress in the number of qubits that can be controlled and measured, as well as in the development of error correction techniques and more scalable quantum computing systems. We may also see advancements in the development of quantum algorithms and applications in various fields, such as drug discovery, cryptography, and machine learning. Potential applications of quantum computing. In cryptography, quantum computing could break current encryption methods and pave the way for more secure communication. In finance, quantum computing could enable faster and more accurate risk assessments and portfolio optimizations. In logistics, quantum computing could optimize supply chain management and transportation routes. In climate modeling, quantum computing could improve the accuracy of weather forecasts and climate simulations. Advantages of quantum computing. Speed. Quantum computing solves certain problems much faster than classical computers, particularly those that involve large complex calculations. Parallelism. Unlike classical computers, which process information sequentially, quantum computers can process multiple calculations simultaneously, thanks to the principles of quantum mechanics. Machine learning. Quantum computing can enhance machine learning algorithms and natural language processing capabilities, leading to improved accuracy and performance. Problems in quantum computing. Decoherence. Quantum computers are highly sensitive to their environment, and any interaction with the environment can cause decoherence, which can lead to errors in the computation. Techniques such as error correction and fault tolerance are being developed to mitigate the effects of decoherence. Scalability. Building large-scale quantum computers is a significant challenge, and many of the current quantum computing systems are limited in the number of qubits they can support. Advances in hardware and software are needed to scale up quantum computing systems. Optimization. Quantum computing is well suited to solving optimization problems, such as those encountered in logistics, scheduling, and resource allocation, where finding the optimal solution is critical. Simulation. Quantum computing can be used to simulate and understand complex quantum systems, such as chemical reactions and materials behavior, which are difficult or impossible to simulate on classical computers. What language is quantum computer? Quantum computing uses a variety of programming languages, depending on the specific quantum computing platform being used. Some common programming languages for quantum computing include Q-Hash, Python, and C++. Q-Hash is a high-level quantum computing programming language developed specifically for quantum computing. Python and C++ are more general-purpose programming languages that have been adapted for quantum computing using libraries and frameworks. These languages are used to write algorithms for quantum computers. Error correction. Due to the high sensitivity of quantum computers to noise and decoherence, error correction is a critical challenge in quantum computing. Developing efficient error correction techniques that can handle the noise and decoherence of large-scale quantum computers is an active area of research. Limited applications. While quantum computing has the potential to revolutionize several fields, it currently has limited practical applications due to the limited number of qubits available and the technical challenges involved in programming quantum computers. How does quantum computing works? Quantum computing works by using qubits, quantum bits, that can exist in multiple states at the same time, allowing quantum computers to perform calculations in parallel. The basic steps involved in quantum computing are initialization. The qubits in a quantum computer are initialized to a specific state, usually a superposition of two or more states. Quantum gates. Quantum gates, similar to logic gates in classical computing, are applied to the qubits to perform operations like entanglement, superposition, and interference. Measurement. The state of the qubits is measured, collapsing the superposition and yielding a classical state that represents the output of the computation. Quantum algorithms. Quantum computing can use unique algorithms that take advantage of the parallelism and entanglement properties of quantum systems to solve specific problems more efficiently than classical computers. The human brain and quantum computers are fundamentally different in the way they process information, so it is difficult to compare their relative computational power directly. The human brain is a highly complex and adaptable biological system, capable of performing a wide range of tasks, including pattern recognition, decision-making, and learning. On the other hand, quantum computers leverage the principles of quantum mechanics to perform complex calculations in parallel and solve certain problems more efficiently than classical computers. Is the human brain more powerful than a quantum computer? Quantum computers have shown promising results in solving specific problems, such as factorization and optimization, that would take exponentially longer time on classical computers. However, building large-scale quantum computers and developing effective error correction techniques remain major challenges. What is the purpose of quantum computing? The purpose of quantum computing is to solve complex problems that are beyond the reach of classical computers. Quantum computers use the principles of quantum mechanics to perform calculations in parallel, which allows them to solve certain problems more efficiently than classical computers. For example, quantum computers can be used to factor large numbers quickly, which is a part of modern cryptography. They can also be used to optimize complex systems, such as supply chains or financial portfolios, by finding the best possible solutions out of a vast number of possibilities. Another potential application of quantum computing is in the simulation of quantum systems, which is challenging for classical computers due to the exponential growth of the computational resources required with increasing system size. What are the three concepts in quantum computing? Quantum computing is based on three fundamental concepts: superposition, entanglement, and quantum measurement. Superposition. In quantum mechanics, a particle can exist in multiple states simultaneously, a concept known as superposition. In quantum computing, qubits, quantum bits, can be in a superposition of 0 and 1, which allows quantum computers to perform calculations in parallel and potentially solve certain problems more efficiently than classical computers. What are the three concepts in quantum computing? Entanglement. Entanglement is a quantum mechanical phenomenon in which two particles can be inextricably linked, such that the state of one particle is instantly affected by the state of the other, regardless of the distance between them. Entanglement can be used to perform certain calculations more efficiently than classical computers. Quantum measurement. Quantum measurement is measuring the state of a qubit. In quantum mechanics, measuring a particle can change its state, so measuring a qubit can cause it to collapse from a superposition of states to a definite state of 0 or 1. Which element is used in quantum computing? Quantum computing can be implemented using various physical systems, such as superconducting circuits, trapped ions, and photonics. These systems use different physical elements to represent qubits, the basic unit of quantum information. For example, superconducting circuits use superconducting electrical circuits to represent qubits, while trapped ions use ions trapped in an electromagnetic field. Photonic systems use light to represent qubits. How many types of quantum computing are there? There are several types of quantum computing that are currently being researched and developed. Topological quantum computing. Topological quantum computing is a type of quantum computing that uses the properties of topological materials to create and manipulate qubits. Adiabatic quantum computing. Adiabatic quantum computing uses the adiabatic theorem to perform quantum operations. Quantum annealing. Quantum annealing is a type of quantum computing that is specialized for solving optimization problems. Your feedback is important to us, so please don't hesitate to leave a comment below if you have any additional study-related questions or topics you'd like us to cover. Stay up to date on the latest content by liking, sharing, and subscribing to our channel, and don't forget to share it with your loved ones. We appreciate your support and look forward to bringing you more informative content in the future. Thank you.